Hi guys, how are you all doing? Welcome back to NSR Programmer Blockchain Webinar Solidity, specifically Remix in Ethereum. So yesterday we looked at view and pure functions. It was a short session. Today we're going to be looking at error handling. So we're going to learn what makes error handling critical in Solidity smart contracts, when and how to use require, revert, and assert functions to validate inputs and protect against bugs, and also how to implement custom errors for gas efficient revert messages. I'm going to cover two practical examples: handling overflow and underflow in token and balance contracts. So yeah, some quick definitions that maybe you'll want to understand before we get straight into the demo. So when I mentioned require, revert, and assert, in Solidity those are special built-in functions. So one is require, one is revert, and the other one is assert. They are all special built-in functions in Solidity, used for error handling and validating conditions during contract execution. They are not ordinary user-defined functions, but language constructs that throw exceptions and undo all state changes made during the current transaction when their conditions fail. So let me try and break down what the require function is. So the require one is used to validate inputs, external conditions, and return values before execution. And then if the condition is false, it reverts the transaction, refunds remaining gas, and optionally shows an error message. It's commonly used for checking user inputs, validating state and external calls. Validating state and external call results. Then the revert function explicitly stops execution and reverts state changes. So it's similar to require, but typically used when error conditions are complex or require nested logic. For example, in if statements. It can also include, this is the revert, can also include an error string message. Then the assert condition or function, it's usually a condition, is reserved for internal errors and sanity checks that should never be false if the contract is correct. So if the condition is false, it reverts but consumes all remaining gas, so no refund. And it also indicates a bug in the contract code, not the user error. Yeah, more key definitions. Just to define what an error is. An error is a condition that prevents execution or indicates a problem. Yeah. Transaction is an action submitted to the blockchain to change contract states. Then define what require is. So require checks conditions before execution. Reverts with an error message. Revert manually stops execution with an error. It's useful for complex conditions. More key definitions. The word assert. I think we covered that. Yeah, covered those. So yeah, a custom error. Yeah, to define what a custom error is, it's a user-defined error type that saves gas compared to string errors. We have another term called overflow. So when a number exceeds the maximum limit of the unsigned integer 256, that's an overflow. And then underflow, when a subtraction attempts to go below 0. So that's an underflow. So it's invalid for unsigned integers. Yeah, so let's look at an example, our first example of the demo. We'll be looking at basic error handling. Yeah, so this first one is for basic error handling. Define a contract called error. Okay, I think it will let me use that name. I'll call it basic. Oh, yeah. Okay.
Instead of me going down, you have 50,000 on mobile money, I give you cash.
Excuse me. Yeah, so here's our first example. Well, this is basic error handling. So let's go through it line by line. So yeah, we defined a contract called basic. We chose the name to just cover what basically we're looking at, which is basic error handling. And the contract has a function from line 6 called test require of an unsigned integer 256. Made it a pure function, yeah, public. So what's happening is that user is required to verify the input of _I is basically greater than 10. Yeah, so if it is false, the transaction stops and error string is returned. Then the next function there, which is also a pure function, function test revert, it uses an if check with the revert function. Yeah, remember the functions we defined at the beginning. The functions we defined at the beginning, which are require, revert, and assert. So here we're using an if check with the revert for similar validation, but suitable for complex conditions. Yeah. And then line 17, unsigned integer 256 public number. That's a state variable initialized to 0 by default. And then line 20, we have a function there, test assert. So that one uses the assert function to ensure the variable num has not changed. Failure indicates an internal bug. So that line 25, error insufficient balance, defines a custom error with parameters. And then line 28, it checks the contract's balance and reverts with custom error if the funds are insufficient. Yeah. We'll interact with them at the end. Let me just do the example. Very quickly. So this one, we're going to be covering overflow and underflow protection with errors. So that's what we're covering in this next example. So let me type it out and then break it down, and then at the end we'll interact with both contracts. Right, so let's break it down from line 5. So we have a contract called account. So from line 5, let's line, basically it holds the user's balance, which is initially 0. And then line 6, the maximum, it sets a maximum value the unsigned integer 256 can hold. Then the function deposit adds amount to balance and then checks for overflow using require. Basically the require function, the built-in Solidity function. And then line 18, assert balance is greater than or equal to balance. It ensures the balance only increased or stayed the same. So it's like a consistency check. Then we have a function called withdraw that checks underflow on withdraw with both require and has a fallback for what? Revert. And then the last line, assert, that ensures the balance decreased or stayed the same after withdraw. So we can compile and then interact. Let's start with the basic. So for the basic error handling, so we can call the test require with value, which is either less than or greater than 10 to cause a revert, and then we'll try it with a value greater than 10 to succeed. So let's try it with a value less than 10 and then call the transaction has been reverted to the next initial steps. Reason provided by the contract, input must be greater than 10. And then now let's try with a value greater than 10. So let's say 15. And then you can do the same with the revert and the assert. So what does the revert function? It should be less than or equal to 10. It should give us a default value. For the custom error. Transaction has been reverted to the initial state. Insufficient balance. Yep. So that's it. We can then look at our other example. So we can call the deposit with a certain value and then check the balance after. So let's say 100. Right. So if we call the balance, here it's at 100. And if we increase this to 10,000, will it accept it? Yep. So now it's 10,100, the balance. Alright, it should be right, yeah. So let's try and call the withdraw, but with a value greater than the current balance to see revert and underflow. So the current balance is 10,100, so let's say 15,000. Yeah, so there's a revert with an underflow here, right? Says the transaction has been reverted to the initial step. Reason provided by the contract, underflow. Exactly. So let's try it with a smaller amount. It's 800. And then so executed. So if we call the balance, it should have reduced 9,003. Right. So yeah, that's it for error handling. I hope you guys learned something. Once again, please don't forget to like the video, share it, subscribe to the channel, leave a comment, it will be very helpful. Thank you for tuning in. Until next week, have a blessed evening.